Okay, these are normal Pythagorean questions. So we'll look at them here. So this is work outside of A. You have the hypotenuse, you have an angle. This is the opposite. So sine 38 is equal to A divided by 7.3. Here, again, it's an opposite angle. So we would have sine. And here, again, it's this opposite. So we'd use sine here as well. Now, this sine theta equals opposite over hypotenuse only works in a right angle triangle. So what happens when we don't have a right angle triangle, for instance here? Now, you can split it up, and if you do a little bit of algebra, you get to this. And basically this states, doesn't matter which side or angle, that a side length and the angle opposite always have the same ratio in a triangle. For instance, C divided by sine C is equal to A divided by sine A, which is equal to B divided by sine B. Or conversely, you can have them reciprocated. So you can have sine C over C equals sine A over A equals sine B over B. Depending on whether you're trying to find the angle or whether you're trying to find a length. Okay, so let's have a look here. If I want to find x, okay, then I know that x divided by sine 38 is equal to 8 over sine 49. Okay, I know that x over sine 72 is 12 over sine 53. I know x over sine 30 is equal to 10.5 over sine 67. So all of those I can work out just by using the ratio that I've been given. Okay, and you can do these yourself and find them there. Now, you can do, if you go back to this question, you can do some revision on this if you want, if you're not too sure about what's going on. That's on page 265, exercise S 5.6. If you want to just go on to do some stuff with sine rule, that's page 267, S 5.7. Now, there is also on top of this a sine rule to find the area, which we'll come back to later, but there's also a cosine rule. Now, this uses the fact, again, we can spread these out and it gives us this equation down here. Now, this is just relating a side and its opposite angle to the two other sides, which means that a side length squared is equal to the other two side lengths squared and then added together, which is Pythagoras' theorem. But then we have this bit here, which states that if the angle is here, for instance, the angle is over a certain amount, that would mean that A would be longer. If A is smaller than a certain amount, it would mean that A would be smaller, and so we take it away, because when cosine A gets over 90 degrees, then this part here becomes positive, because cosine of a number not bigger, greater than 90 is negative. But again, we can use those facts here. So for instance, if I want to work out x, I know that x squared is equal to 6 squared plus 8 squared, take away 2 times 6 times 8 times cosine of 50 degrees. Same here, x squared is 9.4 squared plus 12 squared, take away 2 times 9.4 times 12 times cosine of 80, and the same here, and these are the answers that you should get. Now, the exercise for cosine rule is S 5.8, page 269. Now, very often in an examination, what you'll be asked to do is either work out one of these sides or work out the angle, because then you have to rearrange this equation here. So very often some teachers write it in a different form. So it gives you cos A is equal to A squared minus B squared minus C squared divided by minus 2BC, or B squared plus C squared minus A squared over 2BC. So any one of those there. But I'll put the PowerPoint online, and then I'll also put the questions and then screenshot the book in case you don't have